situated? Okay, so exponential functions. I am kind of going into this assuming that you guys have seen exponential functions before. When we get into logarithms, I'm hoping all of you have done logarithms also. So the basics of exponential functions. Let a and b be real number constants. An exponential function in x is a function that can be written in the form f of x equals a times b to the x power, where a is non-zero, b is positive, and b does not equal 1. The constant a is the initial value of f, the value at x equals 0, and b is the base. And then I removed this part from your notes. I think the next thing in your notes is the logistic population model. So it says here, exponential growth is unrestricted, but population growth often is not. For many populations, the growth begins exponentially, but eventually slows and approaches a limit to growth called the logistic growth function. Let a, b, c, and k be constants with b greater than 1. A logistic growth function in x is a function that can be written in this form or this form, where the constant c is the limit to growth. If b is greater than 1 or if k is less than 0, these formulas yield logistic decay functions. Unless otherwise stated, all logistic functions in this text will be logistics growth functions. Sorry for the typo there. All right, logistic growth functions are not going to have a huge presence on the AP exam. They may not be there at all. If it's there, this is one of those things that it might come in handy to know, or it might not be there. We're not going to spend a whole lot of time on it, but I want to show it to you guys just in case you'll need it. The big difference between logistic functions and exponential functions is that logistic functions have a limit. So you guys already know that exponential functions look something like this. Logistic functions look similar to that at the beginning, but then they kind of curve off. There's an asymptote up here as well. So for example, population growth, or if you guys ever did that experiment, they're creating a formula for the zombie apocalypse, most growth has some kind of ceiling. For example, the zombie apocalypse, eventually everyone in the world is a zombie, and there's no more zombies being created. So it would start to taper off at the end. So depending on your situation, a logistic growth function might be a better model for you guys to use. All right, example number 1. For each model, P represents population of the city proper and T, time and years since 2010. Tell whether the population model of each city is an exponential growth or decay function, and find the growth or decay factor and the constant percentage rate. Okay. Let's see here. Oh dear. Let's do this first. I think all of you guys can identify whether this is a growth or decay function, right? Yeah? Okay, so on your whiteboards, tell me if it's a growth or decay function. You only have one chance to answer because there's only 2 options. Once you have it, hold up your hand. Okay, okay. Okay, good job. Yes, yes. Well done. All right, everyone got it? Awesome job. Okay, the growth or decay factor, in this case the growth factor, that is B. Can you guys, using the first formula that we learned at the top of your notes, can you guys identify B in this equation? So, okay, yes. Good job. So B is 1.0168, and it is an exponential growth function. All right, the next thing they're asking for is the constant percentage rate. All right, let's imagine that you went shopping and you bought a t-shirt. And then later you decided you wanted to buy a second t-shirt, so you went back to the same store, but you discovered that the price had been increased by 20%. So if that's the case, let's imagine that P is the price of the original price of the shirt. The inflated price would be 1.2 times P because it has been increased by 20%. Did that make sense? Now let's imagine you didn't know the percentage that had been increased. You just knew that it was being multiplied by 1.2. Could you figure out the increase from this? How?
1.2 equals the after price.
Yeah, or just subtract 1, right? Yeah, just subtract 1, convert to a percent. So in this case, we are given, it's being multiplied by 1.0168. They want the growth, the percentage of growth, written as a percent. Can you guys do the same thing with that? Okay. So please find the constant percentage rate. And when you have it, please hold up your board. Yes. And as always, once you get it right, please check in with your teammates, make sure everyone understands, ask each other questions, help each other out, and make sure everyone at your table's okay. Yes.
I just don't like this. I think you're like taking a step beyond. No, I just don't like 2.
All right, everyone got it? Great job. Here's the answer. 1.68% increase per year. Are there any questions on example 1? Okay. Okay, does anyone need a little more time to copy this down? It's okay if you do. Just let me know. Okay, here is B. For this one, please tell me, is this a growth or decay function, and what is the growth or decay factor? What's B? So tell me either growth or decay, and then give me B. When you have it, please hold up your board. Okay, both correct. All correct, sorry. Yes, all right, so we have 1, 2, 4, 5, well done. Yes. Yes. Everyone got it? Great job. Here is the answer. All right, here's B. It is an exponential decay function. Any questions? All right, please find the constant percent rate of decrease. And please give it to me as a percent. Nope. So remember, this one has decreased. This is like the price of the shirt has gone down. Let's imagine the price of the shirt has gone down 20%. Now, you're multiplying the original price by this, right? You guys see that? So if you didn't know the percent that it had decreased, you could still use this to find what percent it decreases. Yes, but erase the negative. Erase the trailing zero. Yes. 0.7. Yes, everyone got it. Here is the answer. Okay, real quick. This is one of those things that the AP exam graders are really picky about. If you put that it's a negative 0.7% decrease, even though they know what you mean, technically, negative 7% or 0.7% decrease would be an increase, and they would mark that wrong. Okay, so be super careful about little things like that. If you write something that is technically not true, even if it's clear to everyone what you were trying to say, they will mark it wrong. Oh, because you moved the decimal 2 places to the right? Yeah. All right, do you guys all feel pretty confident identifying exponential functions?
Yes.
So, like, take a look at example number 2. Is that something where you guys feel like you could do without help, or would you like to go one at a time? Would you like me to do one of them first? Or 2 of them? Or just go for it? You feel like you got it? You got it? Is that how everyone feels? Is there at least one person at each table who's like, no, I got this? All right, let's do it. So please tell me, for each of these problems, you guys are telling me, you guys are determining whether or not they are exponential functions. If the answer is yes, it is an exponential function, please give me the initial value and the base. If the answer is no, it's not an exponential function, tell me why. So if the answer is yes, give me the initial value, that's A, and the base, that's B. If the answer is no, explain. You don't have to write a paragraph, just a quick explanation. All right, and when you have all 5, please hold up your board. I'll give you 1 point for each one you get correct. Yeah, give me all your answers at once. So give me all 5. Here's a question. Would it be easier if you just gave me yes or no?
Yes.
Let's do this. Just tell me yes or no for each one. I'll give you 1 point for each one you get correct, and then I'll give out bonus points for the rest. So on your whiteboards, just give me yes or no. I'll give you 1 point for each one you get correct. Just tell me yes, no, 1 through 5, or A through E. Okay, thank you. Can I see it one more time? Okay, thank you. Alice, you had your hand up? Are they exponential functions at all? So the definition of an exponential function is on the first page, if you want to review it. Okay? 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 All right, teams 1 and 3. Give you guys 1 more minute.
My marker? You mean this is just, it's actually my note.
Hold on. Okay, thank you.
I have a reputation.
Oh, okay. Okay.
Guys. Oh, shoot.
Okay. you re-answering?
Yes.
You're not. All right, let's just go over it.
Oh.
All right. It's okay. All right, so the answer to A is yes, it is an exponential function. Let's see here. I will give a bonus point. There's 5 questions, and there's 16. This doesn't add up. We'll start with team 1 and go through, and the team that doesn't get a bonus point, I'll think of something later to give you guys a bonus point. Okay, team 1, can you tell me the initial value on the base? If you don't know, you can pass, and the next team can get the bonus point. For number 1, or for letter A, I should say. The initial value on the base. You're looking for A and B.
Okay. A would be 1, right? And then B would be 3.
Correct. Great job. All right, the answer to number 2 is no. Team 2, bonus point if you can tell me why. So tell me, so it's not an exponential function, so there isn't really an initial value or base. Why isn't it an exponential function? Yes, so the exponential function, the exponent is a constant, not a variable. Perfect. In order to be an exponential function, you have to have an exponent as, a variable as an exponent. All right, the answer to C is yes, team 3. Bonus point if you can give me the initial value and the base.
The initial value would be -2 and the base would be 1.
Perfect. Well done. Ooh. All right, team 4. The answer to D is also yes. Team 4, bonus point if you can give me the initial value and the base.
The initial value is 7.
Mm-hmm.
And the base is 2.
Correct.
Just building suspense.
All right. And E, the answer is no. Team 5, bonus point if you can tell me why.
There's no x that's
Yeah, it's a constant function. Perfect. And team 6, I'll get you a bonus point at some point today. All right, it's not an exponential function because this is just a number. Pi is a number. There's no variable anywhere inside. Well, it's technically an equation. It's a constant function. It is a horizontal line, yes, at some exponent. Exponent, decimal. My brain today, goodness. All right, are there any questions on identifying exponential functions? All right, you guys have learned about E and natural log. So natural log is basically log base E. E is kind of like the pi of calculus. It's a number that you're going to be using for a lot of different things. In this class, we're just kind of getting introduced to E. You're going to be using it when you solve equations. We're not going to be doing much more than that with it. It says, since f of x equals e to the x has special calculus properties that simplify many equations, e is the natural base of exponential functions for calculus purposes, and f of x equals e to the x is considered the natural exponential function. If you're interested, this is what e equals. This is the definition of e. You don't need to know that, but for curious minds, it's there. If you ever needed to change the base of a function to e, you can do that by figuring out some coefficient for x. All right. For an appropriately chosen real number constant k, if a is greater than 0 and k is greater than 0, this is a growth function. Otherwise, it's a decay function. This is just following the previous definition. All right. I did want to give you guys the last 15 minutes to work on homework. Looking at the time, would you guys be completely heartbroken if I just went over the last few problems? Or would you rather do them? Would you like to?
Yeah.
Which one? Go over it? Or me do it or you do it? Me, okay. Everyone's okay with that? All right, let's do it. Okay, so describe how to transform the graph of f of x equals e to the x into the graph of the given function, then sketch both graphs. Sorry for the smudging there. All right, so in each of these cases, this graph is in blue and this graph is in pink. You're also welcome to graph it on your calculator so you can see a little bit more clearly. This has a horizontal dilation by a factor of 1/2. There's blue, there's pink. This one is a reflection across the y-axis. Here's e to the x, here's e to the negative x. Sorry, going too fast? My bad. Yes, I can. And here's number 2, or letter B. And then this is a vertical dilation by a factor of 3. This is the only one where the y-intercept changes. Does anyone need a little bit more time? It's okay if you do. Just let me know. Yes. That's as high as I can go. Is that all right? You know what, Team 6, I'm just going to give you a bonus point.
Whoa.
Everyone else got a bonus point. I'm out of questions. You did great. You did great.
Yeah, I think this is like, I think table 4 needs a little bit more.
All right, here is the exit ticket. All right, so ladies, this exit ticket was meant to just kind of review some of the basic graphs. These are all graphs that you guys should know, hopefully, and then also reviewing limit notation. So they wanted the end behavior using limits, This one, as x approaches infinity, y is approaching infinity. As x approaches negative infinity, y is approaching negative infinity. This one, it's going up and up, so infinity for both. This one's also up and up, infinity for both. That's my alarm saying it's time for homework. This one is going down this way, up this way, so infinity, negative infinity. And finally, as x approaches infinity, this equals infinity, but x does not approach negative infinity, so this limit does not exist. I went through that really fast. I'll go back and slower. Here are the first two. All right, here are the next two. And here is the last one. Are there any questions on any of these? All right, you guys did an outstanding job. There's about 14 minutes left in class. You're welcome to take out your devices. You can grab your cell phones. You have the rest of the block to work on your homework. I'm available for questions if you have them.